Hey math kids, today we're going to talk about arithmetic operations with complex numbers. So to start off, let's talk about what a complex number is. But before that, let's talk about what an imaginary number is. So up until this point, I think you've been taught that if we ever take the square root of a negative number, that is just undefined. So that's not totally true, but in the context of like previous math classes, I think it's fine to talk about it that way. But now we're going to actually talk about it in the fully correct way. So we're going to start with just the square root of -1, and we're going to define that as I. So anytime we see this lowercase I like this, it really means the square root of -1. And so if we have something that is, let's see, how do I want to do this? I want to actually talk about the next power of I too. And then we'll move on to complex numbers. So if I were to just square this side, square this side, I'd end up with I squared over here. But on this side, this square would cancel the square root, and so it's actually just equal to -1. So I squared is -1, and I is the square root of -1. Now, these are the two main relationships we're going to use in the class, but I just want to show you kind of a property of what happens as we continue to increase the power of I. So if we do I squared times I, we'll end up with I cubed, because it's like 2 plus 1 is 3. And so if we do the square root of -1, so I squared is -1, and if we times that by the square root of -1, just doing this piece, then we'd get this. So if we simplify that, it's the negative square root of -1. Now, a lot of kids have a problem with that because they really want to cancel those negatives, but since we have that radical sign in between, we can't do it. So once again, I cubed is equal to this. We're not going to use that a lot in the class, but just so you know. Now, if we do I squared times I squared, we get I to the 4th. I squared is just -1, so that's -1 times -1, which is 1, and so I to the 4th is just 1. And then if we do one more, I to the 4th times I would give us I to the 5th, and I to the 4th is just 1, and I is the square root of -1. So we kind of went full circle. So I to the 5th is really just I. And so it's just going to loop and loop and loop like that. So just to be clear, I squared, I cubed, I to the 4th is equal to I to the 5th, I to the 6th, I to the 7th, I to the 8th, I to the 9th, 10th, 11th, 12th, and this pattern will just continue forever. Once again, we're not going to use a ton of this. You want to come back up, and the two main relationships are I is equal to the square root of -1, and I squared is equal to -1. These are the ones we're going to use the most. So if that other stuff kind of confused you, try to just take it as like a FYI. I think it's interesting. I think it's cool that it loops around like that, but in this class we don't use that often or at all. Now, taking what we know about imaginary numbers now, we're going to talk about complex numbers. So complex numbers can be purely imaginary, so it can be 2i. It can be purely real, so it can just be the number 3, or it can be something like this, where we have a real part and we have an imaginary part. Okay. So what we're going to focus on is how to do arithmetic with this. So how to add, subtract, and multiply specifically. We actually don't get into division, but if you're curious about it, you can come to Math Lab and I can show you how to do the division, but I won't do it on this video. Okay, so I'm going to introduce something that I use a lot in this class. It's just this box. And so if you ever see this box, it's going to be filled with a couple different operations. In this case, the box is going to be defined as addition, subtraction, multiplication. So if you see this with the box, and the box has been defined like this is really 3 problems in one. So first we're going to treat it like a plus sign. If we're adding imaginary numbers, then we just combine like terms. That's it. So since this is a real number, this is a real number, 3 plus 7, we get 10. Since this is an imaginary number, this is an imaginary number, 4 plus 2 is 6i. And that's all we do for addition. Okay, subtraction works in a similar way. We change that to subtraction, and we just subtract like terms. Or, in my opinion, it's actually safer to distribute a negative and then write a new problem. If you feel really confident that you won't mess that up, you don't have to do that, but I distributed a negative, so I'm changing all the signs just on the second part, and then it becomes an addition problem. And so my answer for subtraction is going to be 3 and negative 7, so that's negative 4. And then 2 and negative 4 would be negative 2i. Okay, last piece of this, we multiply. So that's now multiplication. For multiplication, we distribute. So 3 times 7, so this is my multiplication answer. 3 times 7 is going to give me 21. 3 times 4i is going to give me 12i. 2i times 7 is going to give me 14i. And then 2i times 4i is going to give me 8i squared. Okay, now we need to simplify things. So we simplify these. We get 21. And then combine like terms, that's going to be 26i. And then 8i squared. Now we're actually not done. It looks like we might be done. But we want to remember that I squared is equal to negative 1. So this now becomes this piece, 8 times negative 1, which would be negative 8. So this negative 8 can combine with this 21 because they're both constants. So if we take away 8 from this, we get 13, and then we still have the 26i. And so that's the multiplication answer. And that problem's done. So let's go through one more of those. Okay. So first we're going to add these. Adding, we just combine like terms. 5 plus 2 is 7. 6 plus, this is a 1, is 7 also, so 7i. Subtraction, pretty straightforward. We just change these, all the signs. So if they're positive, make them negative. If they're negative, make them positive. So 5 and negative 2 is 3. 6 and negative 1 is 5i. Now moving on to multiplication. We want to get rid of these blue pieces. Let's just erase those so they're not confusing. So we only use that in the subtraction, so we don't need those anymore. Now we want to distribute. 5 times 2 is 10. 5 times I is 5i. 6 times 2, or 6i times 2 is 12i. And then 6i times I would be 6i squared. Once again, we combine the middle terms. And then we know this is -1, so this will turn into a -6. A shortcut you can think of, cross out the I squared, change the sign. So that's going to be a 10 and a -6, which makes 4. And then we still have our 17i. And so our answer for multiplication is that. Okay? We have 2 more types of problem. So we're going to move on to the next type. So square root of -36 plus square root of 25. Now, the directions on this are to write the following expressions in a plus bi form. So it wants us to write a real number plus a imaginary number. So to do that, right here we have a negative sign. We're going to ignore it just for a second. The square root of 36 would give us 6, but since it was negative, it's 6i. Over here, 25, square root of 25 would be 5. Now this isn't quite in the right order, so we just flip them around. So we get 5 plus 6i, and now it matches that form, and so we're done with that. Let's do just one more to be clear. Square root of 64 plus square root of -1. Square root of 64 is 8. Square root of -1 is I. And then this actually is already in the right form. We have our real part, then our imaginary part. So we're done. Okay, and the last type of problem is similar to what you did on your last homework, but this time we're involving negative numbers. So what we want to do is distribute. So this one, since they're both under a square root, we will actually multiply them. So -18 under square root. Since this 3 is under square root, this one's not, we just write them next to each other like that. Now we can break up the -18 in a couple ways. So -18 is going to be 9 and 2, 3 and 3. If we have a pair of 3's, a single 2. So the 3 can come out as a single 3. We leave the 2, but it was negative, so we think of it as a 3i on the outside. And then we still have the 3 square root of 3. And that would be our answer on that one. And let's just do one more like that. So let's do square root of 5 times square root of -2 plus 6. Once again, our goal is to distribute. So they're both under a square root, so we actually multiply them. 6 is not under square root, 5 is, so we say 6 root 5. And we want to take it just one step further to take out this I. So 10 just breaks up into a 2 and a 5, so we can't change that. So we still get the square root of 10, but this negative comes out to become an I on the outside, and then we just rewrite our 6 root of 5. Okay, if you need additional help, please come to Math Lab. For now, calculator.